In this module, you will learn about the Lewis structure and covalent bonds of atoms. Drawing the atomic structures of complex compounds with bonds is difficult. To overcome this, Lewis established an easy way to represent bonds within molecules and ions. He created it as per the shared pair of electrons and the octet rule. In his method, electrons are drawn as dots and the bonding of a pair of electrons is represented by a line. Therefore, it is also known as the electron dot structure. The Lewis structure for an atom is the chemical symbol for the atom, surrounded by as many number of dots as the number of valence electrons in it. For an ion of an element, we first need to draw the chemical symbol for the element surrounded by the number of valence electrons present in the ion. Then, the whole structure is placed within square brackets, with the superscript indicating the charge on the ion. The charge of the ion is the number of electrons gained or lost. To draw the Lewis structure for a molecule, first draw the atoms and join them with lines so that for each atom, the total number of valence electrons becomes 8. To draw the Lewis structure for compounds, first, the unit of the negative or positive charge should be deducted from the total number of valence electrons of the compound. The remaining number of valence electrons should be distributed as the bonding pairs of electrons. For example, a carbonate ion has 2 negatively charged units. The number of valence electrons in a carbonate ion is the sum of valence electrons of 3 oxygen atoms and the valence electrons of the carbon atom. That is 22. Therefore, the number of electrons to be distributed in a carbonate ion will be 22 minus negative 2, that is 24. In the Lewis structure, the least electronegative atom occupies the central position, which is carbon here. Now, when 24 electrons are distributed among 3 oxygen and 1 carbon atoms, it looks like this. After assigning electrons, the remaining electrons are utilized for multiple bonds or remain as lone pairs. We will replace each pair of bonded electrons with a line. Notice that the total number of valence electrons becomes 8 for each atom. With the sharing of valence electrons for the full octet in each atom, the Lewis structure involves the octet rule. However, there are some molecules in nature that do not follow the octet rule. In some molecules, the number of electrons surrounding the central atom is less than 8. For example, beryllium hydride and boron trichloride have 2 and 3 pairs of electrons respectively surrounding the central atom. In molecules with an odd number of electrons, such as nitric oxide, the octet rule is not satisfied. The octet rule also does not apply to the molecules with expanded octets. Though the octet rule is based on the inertness of noble gases, some noble gases such as xenon and krypton react with other elements and form compounds. The octet theory also does not explain the shapes of molecules and energies of orbitals. However, the molecules that do not follow the octet rule can still be represented by the Lewis electron dot structure. Therefore, Though the Lewis structure involves the octet rule, it is not limited to the octet rule. However, in case of polyatomic molecules, there can be more than one possible Lewis structures for a molecule. To determine the best possible Lewis structure for a molecule, we need to find out the structure with the lowest energy from a number of possible Lewis structures. The lowest energy structure is the structure with the smallest formal charge on the atom. Formal charge is the charge assigned to an atom in a molecule, assuming that electrons are shared equally between atoms in a chemical bond. For the correct Lewis structure, it should be other than 0. The formal charge can be expressed as the difference between the number of electrons present in that atom in its isolated state and the number of electrons assigned to the atom in the Lewis structure. For example, in a phosphine molecule, the number of valence electrons in the phosphorus atom is 5 and the number of lone pairs is 2. There are 6 shared electrons among 3 hydrogen atoms and 1 phosphorus atom. Therefore, the formal charge is 5 minus 2, minus half of 6, which is 3. This gives us the formal charge as 0. The Lewis structure and formal charges are applicable only to the molecules formed by covalent bonding. Let's understand what a covalent bond is. In 1919, with the help of Lewis postulates, Langmuir brought in the term covalent bond to define a bonding pattern where the electrons are not transferred. In covalent bonding, atoms share electrons so that the number of valence electrons in each atom becomes 8. For hydrogen, it is 2. Here, the nuclei of both the atoms keep attracting the shared electrons and do not give away any electron completely, unlike ionic bonding. For example, in a water molecule, one oxygen atom shares valence electrons with 2 hydrogen atoms. In this way, the valence electrons in an oxygen atom will be 8, and thus, oxygen gets the stable status of its nearest noble gas, neon. On the other hand, by sharing 1 electron of oxygen each, the hydrogen atoms will have 2 valence electrons each. It will get the configuration of helium. When 2 atoms share 1 electron pair, they form a single covalent bond. For example, the fluorine molecule. When 2 atoms share more than 1 electron pair, they form multiple bonds. In the ethylene molecule, the 2 carbon atoms share 2 pairs of electrons and a double bond is formed between the 2 atoms. Nitrogen molecules form triple bonds. This brings you to the end of this module. In this module, you learned that in the Lewis structure, electrons are drawn as dots and the bonding of a pair of electrons is represented by a line. The Lewis structure for an atom is the chemical symbol for the atom, surrounded by as many dots as the number of valence electrons. The difference between the number of electrons present in that atom in its isolated state and the number of electrons assigned to the atom in the Lewis structure is called the formal charge of the atom. In covalent bonding, atoms share electrons so that the number of valence electrons in each atom becomes 8. Formation of covalent bonds in gaseous elements involves formation of cation, formation of anion, combination of opposite charges.